In previous lecture, we studied for the example of the spin one half system. And spin one half system, there are two states, spin up and spin down. So it can be regarded a two-level system. And we generalize more generalized to the two-level system. Basically, here H0 is that very well defined energy eigenvalue, so it is a diagonalized Hamiltonian, and the diagonalized Hamiltonian in the zeroth order, and here E10 and E20. Here 1, 2 means that level, first state and second state, and H prime it is unperturbed. It is perturbed Hamiltonian. Then the perturbed Hamiltonian can be have the general expression like H11, H12 prime, H21 prime, H22 prime. It is a general 2 by 2 matrix. In general, in the matrix representation, and the Hij prime can be written down as H prime by the under the basis of the I0 and J0. Here the Hamiltonian can be written down H0 plus lambda H prime, and here we denote that lambda as a parameter. So general Hamiltonian is that E10 plus lambda H11 prime, and also here E20 and plus lambda H22 prime, and lambda H12 prime, lambda H21 prime. Then in general, so this can be write down A, B, C. Here it should be C star, and here because here it is H Hamiltonian is Hermitian. Hamiltonian Hermitian, so it means that Hamiltonian is staggered, complex conjugate, and complex conjugate and transpose. And Hermitian means that complex conjugate and transpose should be identical. So in this case, and A cannot be A does not attribute it to the transpose. So and here and C and C star should be complex conjugate relationship. And here to diagonalize this Hamiltonian, and we need to diagonalize like energy. Energy is that diagonalized parameter, and B minus E and C star should be 0. Then it is A minus E and B minus E minus C square should be 0. And in this case, E square minus E A plus B plus AB minus C square equal to 0. Then E is that 1/2 A plus B plus minus square roots, and A plus B square minus AB plus C square. Here then it is A plus B square minus 4AB. Then it is 1/4 A square minus 2AB plus B square. So it is 1 half a plus b plus minus square root a minus b square plus c square. And because perturbation is very small, so and we should remark that here c is very small comparing to the a minus b. So this energy is the 1 half a plus b plus minus 1 half a minus b. Then it is 1 plus a minus b square for c square to the 1 half. And it can be approximated by 1 half a plus b plus minus 1 half a minus b 1 plus a minus b square to c square. So there are two solutions of energy, and the first solution is then 1 half a plus b plus 1 half a minus b plus a minus b cancel with each other 1 half, and also a minus c square over a minus b. Then it can be write down as a plus c square over a minus b. The other solution is that 1 half a plus b minus 1 half a minus b minus c square over a minus b. Then here b minus c square over a minus b. Then we should remind that what is a and b, c. A here, a is that here, b is that here, c and d. We should remind here. Then by keeping in mind, and so E1 is A is that E10 plus lambda H11 prime plus A minus B C square. C square is that lambda square H12 prime square, and A is that E10 plus lambda H11 prime, then minus B is that E20 minus lambda H22 prime. So it can be approximated by E10 plus lambda H11 prime plus, and here we can assume that in the H11 prime and H22 prime it is close with each other, so we can cancel with each other. So in the lambda square H12 prime square over E10 minus E20. Then like this, and the E2 is that B is that E20 plus lambda H22 prime and minus C square lambda square H12 prime square, and the A minus B, it is A minus B. here like this. So it also can be approximated by E20 minus plus lambda h 22 prime plus E20 minus E10 lambda square h21 prime square. Here 1 2 prime and 2 1 it is Hermitian, so we can write down like this. And here in this case, and we should keep in mind that this denominator should not be 0. So here we should remind that here E10 should not be E20, and it should not be degenerated. It is a non-degenerate. So it should be non-degenerated. So we call it a non-degenerated perturbation. And but what do you think about that degenerated case? And the degenerated case should have the different theoretical formulation. So here we only restricted by the non-degenerated perturbation. So it is a general. We can see that it is we determined this by using this general Hamiltonian. General Hamiltonian is that the perturbed Hamiltonian plus unperturbed Hamiltonian, and because it is not diagonalized, we carried out the diagonalization, then we can obtain the two eigenvalue system, and it is a two-level system, and the two-level eigenvalue can be summarized like this.